So you all have no idea what that possibly could have been now. You didn't see anything. It's still a surprise. Okay. It's all good. So we just ran a different command, and things got magically faster. That was React Compiler, so you kind of figured that out, I guess. But it's React Compiler. It's a tool we've been developing at Meta over the last few years. React Compiler automatically optimizes your components and hooks so that only the minimal parts of your UI update as state changes. So that seemed pretty magical. How could that possibly work? It's really not so scary, so let's walk through it. First, let me explain what I mean by compiler. We hear a lot about compilers these days to refer to all different kinds of tools that transform code ahead of time. There's been a lot of really great exploration in this space, and it's so exciting to see all the different approaches. React Compiler is more like TypeScript, or the compilers inside JavaScript engines like V8 or Hermes. It breaks your code down into individual expressions and builds up a control flow and data flow graph. It performs sophisticated optimizations, like dead code elimination, constant propagation, type inference even, alias analysis, and a whole bunch more. If you aren't familiar with these terms, that's OK. The whole point is React Compiler does that for you. These are optimizations that would typically appear, again, inside a JavaScript engine or compilers for languages like Rust or C++. With React Compiler, we're applying these ideas to improve performance without sacrificing developer experience. The code you write doesn't change. You saw that it was just the original React code right from that component. And our apps get faster by default. In particular, updates get faster by default. In fact, our code gets even more clean and concise because we don't need manual memoization. So that's what I mean by compiler, but what is it doing? How does it actually make that work? So let's go back to that media player example from earlier. This is a really concise, clear description of our UI logic. There's really nothing extra or unnecessary here. No use memo calls, no random unnecessary callback functions, just clean code describing the values we want to show in our UI. But there's a lot of information contained in this code that we might not always think about. For example, consider the filtered songs list. From reading the code, we know that filtered songs depends upon songs. Whenever songs changes, React is obviously going to have to filter that songs list again and update the playlist. This code also tells us the inverse. If songs doesn't change, then React shouldn't have to update the filtered songs, and it doesn't need to update the playlist. And as Satya showed, that's exactly what happens with the compiler enabled. We don't have to update the playlist when songs isn't changing. Now, we're able to understand this because JavaScript and React have clear rules for how they work. And we've learned those rules. We use them every day as we're reading code, writing code, debugging code, and occasionally testing code. We can also teach a compiler to understand those rules. The compiler sees this code very much the way that we do, except it's way more thorough, applying the same process to every value in our code, creating a computation graph of how your data moves through your UI. So this gives an idea of how React Compiler sees your code. But as I mentioned, the compiler knows the rules of React. And it knows some extra things. For example, it knows that set state functions don't actually change. So the compiler doesn't have to consider whether that value could update. So we can remove that dependency edge. So now we know that if setSong gets called and the song changes, from this graph we can clearly see the only thing we have to update is now playing, not the playlist. So this explains the behavior that we just saw in that demo. But the best part is that all this information comes from the same React components and hooks that you're already writing today. There's no API to learn. There's no need to change the way you write code. We can simply take advantage of all the information that's already right there in your code today. Some folks describe these type of precise UI updates as fine-grained reactivity, which I think is a pretty apt term to describe it. But as we've shown, We don't need anything new. All the information is already right there within your React code. Now, that all sounds great, and I know when I see a demo, I'm skeptical. Does it work in prod, right? Well, I'm excited to share that we've been using React Compiler in production at Meta since early last year with exciting results. To tell you more, here's Mofe.